we are gonna do is, if your base, some base b to the power of m is equal to base to the power of n, then I can directly say m is equal to n. This is your first method. Okay, so example, if I give for this thing, example is, if I take here, let me write an example here. If I say here, Caesar, 8 to the power of 5 is equal to 8 to the power of x. What do you get from this thing?
X equals 5.
X is equal to 5, yes. Since my base is the same, my exponents become equal. That's the first method. But there is steps to solve this equation. First, you will write the equation in the form b to the power of n is equal to b to the power of n. Step 2 is set m is equal to n. Step 3 is solve for the variable. This is a pretty direct question you saw, where 8 to the power of 5 was equal to 8 to the power of x, and you directly said x is equal to 5. But suppose you get a problem like, I say 2 to the power of 3x minus 8 is equal to 16. I say solve this. You have to solve this. Okay, first method you're gonna try is, you're gonna try to make your base same. Either you're gonna make this as 16, or you're gonna make this as 2 to the power of something. Okay, I usually make the higher number as the lower ones. So 16 I would like to write as 2 to the power of something. Can you write 16 as 2 to the power of something?
To the power of 4.
Yes. And how did you do? You make factors, right? What are the factors of 16?
4 and 4.
4 and 4. And 4 is?
2, 2.
And then 2, 2. So basically I can write 16 as 2 to the power of 4. That's your step 1.
Professor, I have a question.
Yeah, Kat.
I know I joined class a little late today, but it says there's only 3 participants.
Yes. The reason is, you know why, Kat? Because my internet was not working, and I was like, I will upload my lecture on Canvas, but it started working. So if you want to stay back, you can stay back, or if you want to watch the lecture later, you can on Canvas.
So this is like the new stuff?
Yes, this is the new stuff. I'll be uploading this lecture, yes.
I just have like work
Yeah.
tomorrow, Friday, so I was like, I can't really miss this lecture. I was not going to watch it until like Saturday or Sunday.
So if you want to stay back, you can most welcome to stay back, okay? Okay. So now here you have your base same. What's your step 2? Can you tell me, Caesar?
Make 3x minus 8 equal to 4.
Exactly. Now since I made my bases same, I can put my exponents equal to each other. So I get 3x minus 8 is equal to 4. And step 3 is solve for variable. So basically you have to solve for x. Kat, can you help me solve for x, this thing?
Yeah, I just finished writing down the steps, so
Okay.
I'm gonna figure it out. Let's see. You said 3x minus 8 is the question?
Yeah, 3x minus 8 is equal to 4.
So equals x. Would you do 3 to the exponent 8 minus x equals 4? Is that?
No. You need to solve for x.
Oh, okay. You would add 8 on both sides.
Okay, you get 3x is equal to 12.
And then you divide 3 and you get x equals to 4.
Perfect. And that's your answer. So did you understand this problem, Kat, or no?
Yeah.
Okay.
I did.
Okay. You want me to explain, or you got it?
I got it.
Okay, perfect. So this was your first method. So you try to make your base same. Let's do one more problem. On this. Okay. You are given 27 to the power of x plus 3 is equal to 9 to the power of x minus 1. This is my second problem. 27 to the power of x plus 3 is equal to 9 to the power of x minus 1. Okay. Caesar, can you tell me, can I write 27 as 9 to the power of something or 9 as 27 to the power of something?
No, but you can make it like 3 to the power of 3,
Exactly. And 9 as?
3 to the power of 2.
Exactly. So I can make both of them as 3 to the power of something. How do I know it is? Make factors. Make factors of 27. When you make factors of 27, it will be 9 times 3. And 9 is 3 times 3. And if I make factors of 9 here, it's 3 times 3. I see both of them have common as 3 as their factor. So I'll write 27 as 3 to the power of 3. And it will be x plus 3. And then here will be 3 to the power of 2. Because 2 of them makes it. Then it will be x to the power of 2 to the power of x minus 1. In this case, when you open the bracket, you have to multiply this 3 with each and every term here. You have to distribute, not just with one term, with both terms. So it will become 3 to the power of 3x plus 9 is equal to 3 to the power of 2x minus 2. Kat, what's the next step?
You would solve for the variable?
Yeah, so for no, first what do you do? So step 1 was, see here, step 1 said, rewrite the equation in the form b to the power of m is equal to b to the power of n. So I did that. I made my base same, right? b to the power of m is equal to b to the power of n. Next step says set m is equal to n.
Okay. I thought it was already like that though.
See here, you know what you do is mn is power. So what it says is, what the question says, if you can make your base same, since I made my both base as 3, right? Then I can put just exponential equal to each other. Exponents equal to each other. I don't have to worry about the bases.
Oh, okay.
That's what it says. That's what the first kind of problem we are doing. Okay, and then you have to solve for x. Caesar, help me solve for x.
I subtracted 2x and then subtracted 9.
But x is equal to?
Negative 11.
Negative 11. Perfect. Okay. I want you both to try these problems, and one problem you'll help me, one problem she'll help me. It is 3x minus 6 is equal to 125, and the other problem is 8 to the power of x plus 2 is equal to 4 to the power of x minus 3. Kat, you will help me with problem 1, and Caesar, you will help me with problem 2.
Okay. So, problem 1, I believe we already have a base of 5 on the left side of the equation. So we're going to keep that the same, right? And then on the other side, you're going to want to find the base of 5 as well. So you're going to, it's 125 divided by 5 equals 25 times 5.
Okay.
And then it would be 5 times 5 times 5, right? So 5 to the third.
Okay, that's your step 1. Now you make your base same, power different. Then what do you do?
You would just keep the bases the same and bring down 3x minus 6 equals 3.
Perfect. Yes.
And then you would solve for x, so you would add 6 on each side, which would equal 3x equals 9, and then you divide by 3 on both sides. x equals 3.
Perfect. Really good. Really good, Cat. Caesar, did you get the second one?
Yes. So I made them the same base of 2.
Okay.
So 8 to the power of x plus 2, I turned that into 2 to the power of 3 to the power of x plus 2. And then the 4, I turned into 2 to the power of 2 to the power of x minus 3.
Okay. When you open the bracket, what did you get?
Distributed the 3, so I got 2 to the power of 3x plus 6. Then I distributed the 2, so I got 2 to the power of 2x minus 6. And then I made the powers equal to each other, so 3x plus 6 equals 2x minus 6. I subtracted over the 2x and subtracted over positive 6. And I got x equals negative 12.
Perfect. So one thing I want to specify in this thing is very common mistake is not distributing. When you're writing 2 to the power of 3 and you have x plus 2, make sure to distribute. You have to multiply this 3 with x also and with 2 also, not just x. That's a very common mistake here. Make sure you distribute. So this is an important step here of distributing. Okay. So first kind of problem we did so far today is we are trying to make the base same, and if we could make the base same, we put the exponential powers equal to each other. We made the base same and then we put the powers equal to each other and then we solve. Another kind of problem could be when we cannot put our bases same, when we cannot make our bases same. So example, if I say 4 to the power of x is equal to 15, I say solve this. 4 to the power of x is equal to 15. Factors of 4 I know is 2 and 2. Factors of 15 is 3 and 5. They don't have the same factors, so I cannot write it. So then comes the second method. So first method we did was when the bases are the same and then the powers are equal to each other. Second method is, okay, what you're gonna do in this case is step 1. When bases are not same, when it's not possible to make the bases same. When it's not possible to make the bases same, what you're going to do is, first step is isolate the exponential expression. So I want exponential term on one side, everything else on the other side. Step 2 says take the common logarithm common logarithm, that means log, on both sides if you see 10 in the question. If you see somewhere 10, 100 or factors of 10, or you can say 10 of factors of 10, 10, 100, 1000, 10,000. If you see something like this, 10, 100, 1000, 10,000 and so on, you're gonna take log on both sides. Otherwise, take natural log, which is ln, on both sides. Okay, you will understand by steps. It's easy, you'll understand it. Okay, then you're gonna use simplify using one of the properties. We already know ln b to the power of x In this case, what happens is it picks up this x and throws in front. Power property, which we have already done. Or you're going to use the property as ln e to the power of x. Can you tell me, Caesar, what is ln e to the power of x equal to? What is ln? Log base what?
10.
ln e. ln is base e.
Oh yeah, we did go over that the other day.
ln is always base e. So if you have ln e to the power of x, it comes out to be equal to what?
I'm sorry, I missed it. What are you?
It's x. So when you have log e to the power of x, your base and your base of the log and base of the exponential, if they are same, they cancel out and it's equal to just x. Or third property we will be using is if you have log 10 to the power of x, it is always equal to x. These are the three properties which we have already done. We'll be using one of these properties to solve. And step 4 is solve for variable.
So ln, what do those properties say? So ln
b to the power of x is equal to, remember log, what does it do? It throws the power in front. It becomes,
so ln is just log.
It's just log. It's just
Okay.
log, but it's known as natural log. This is known as natural log, and just log is known as common log.
Okay, so these are the properties we were doing like these last couple. Okay.
Exactly.
Okay.
So first method we did is we tried to make our base same. If the bases were same, we put the exponential equal to each other. Next step is you try to make base same. But if it's not possible, you're going to go to the second method. Okay, example. Let's do example. So you're given 4 to the power of x is equal to 15. And I saw when I was trying to make the base same, I could not make my bases same in this specific problem. Then I'm going to use this method. First step says isolate the exponential power. So I want exponential term on one side, everything else on the other side. In this problem, it's already done. My exponential term is already on one side. Everything else is on the other side. So I don't have to worry about my step 1. Step 2 is take common log on both sides. If you see 10 factors of 10 in the question here, do you see here, cat? Do you see 10, 100, 1000, 10,000 like this here? You don't see it. Since you don't see anything like that, you're going to take ln on both sides. If you ln, so it will become ln 4x or ln 15. If you see 10, 100, 1000 something, you will take log. Otherwise, you're going to take ln. Okay. Once you did this, okay, I have to use one of these properties. Which one do you think, Kat, I'm going to use?
It would probably be ln ex equals x.
Do you see e here?
Oh, like in our equation?
Here, yeah.
Would 4 be e?
4 is b here. This b is just any number. So basically it's this thing. When e, you will see e here. For 10, you will see 10 here.
Oh, okay. So would it be the first one?
Yes.
ln bx equals
x ln b. So what does this become? ln 4 to the power of x.
4 ln 15.
So what happens is it will, whenever you have a power, here, cat, what happens is, what does log do is it picks up this power and throws in front. That's what log does. So it will pick this power and throw in front. It will become x ln 4.
Oh, so it would be x times 4 equals ln 15.
Yeah, it just picks it up this power and throws in front. That's what it does, log.
Yeah, that makes sense.
Okay. Now I need just x. What do I do?
You need x by itself, you mean?
Yes, I need x by itself.
You would have to put everything else on the right side.
Yes, I don't need ln4. What is ln4 doing with x?
I'm not sure.
Is it adding, subtracting, multiplying, or dividing?
Adding?
Do you see plus sign here?
I don't see any sign. I just see ln.
If there is nothing, that means it's multiplying.
Oh, okay.
So you're going to divide both sides with ln4. So basically you get x is equal to ln 15 divided by ln 4. And you can use your calculator to find the values here. So if you open your calculator here, ln is here. So you write ln and then write 15. Make sure you close the bracket. Then divided by ln 4. Make sure you close the bracket.
Which on the calculator is ln?
See, it will be written here. See here, ln. So you get 1.95 approximate. Let's do one more problem here. Okay. In this second problem, you are given 10 to the power of x is equal to 120,000. 10 to the power of x is equal to 120,000. So for this problem here, first I will try to make my base same. Here I have 10. Can I write 120,000 as 10 to the power of something? No, because 10 to the power of something will be either 10, 100, 1000, 10,000, 100,000. It won't be 120,000. So I cannot write 120,000 as 10 to the power of something. So that means I have to go to my second method. I need to isolate my exponential term and everything else on the other side. So exponential term means some base to the power. I will keep on one side, everything else on the other side, which is already done in this problem. Next step is step 2. Okay. See, so do you see anywhere 10 in this question?
Yes.
Since you have 10, you will not take ln, you will take log.
Okay. Oh, okay. So as long as there's a single 10 in there, you have to use log.
Yes, you have to use single 10. 10, 100, 1000, 10,000. Then you will take log. Otherwise, you will always take ln. Okay. Now I have to use the steps. Okay. If there is no base here, if there is, which of the properties I am using here? I had 3 properties here. Which property do you think I'm using here now, Cat? 1, 2 or 3?
You would be using the third one?
Yeah. What is, I have log 10 to the power of x. What is it equal to?
X.
So you will get basically x here from this. This whole thing just becomes x is equal to log 120,000. And you use your calculator to find the value of log 120,000. So in this case, you will not use ln now. There is log here on your calculator. Log, then you'll put 120,000. Close the bracket, enter. So you get 5.079. Now both of you will try this problem here. 5 to the power of x is equal to 134, and the second problem is 10 to the power of x is equal to 8,000. Try these 2 problems.
Professor,
Yeah.
I don't think I got all three of the properties down.
Okay.
Yeah.
I've got two. Could I just see them real
Yeah,
quick
yeah.
so I could write the rest
So
down?
this is first, this is second, and this is third here.
Okay. X. Okay. Perfect. Thank you.
I still need it. Hold on.
Okay, yeah, it's okay. Yeah, take your time.
And
So it's the first one is ln bx equals x ln b, right?
Yes, yes.
Okay.
Bless you.
oh, thank you.
Done, Caesar?
Yep.
Okay. So try these two problems, both of you, yeah.
Quick question.
Mm-hmm.
The b, what is the b equal?
B could be any
compared
number.
to
5, 6, 10,000, 10,000. B could be any number.
any number, and then the e equals what?
E is just a number which is 2 point something, but you don't need to know. It is a special kind of number.
So the equation that we would use in the first one would be ln bx equals x ln b.
Yeah, so why you're gonna use, see here, cat. First of all, can you write 134 as 5 to the power of something?
Probably.
Let's see, 134. Let's make factors of 134. What can you divide 134 with?
2.
Yes, you can divide 2. When you divide by 2, you get 67.
And then 67.
67 you
you
cannot
can
divide with
by 2.
anything, so it remains as it is. So you cannot write 134 as 5 to the power of something. Okay, so that means I have to go to my second method now. Okay, I need to isolate my exponential term on one side, everything else on the other side, which is already done here. I have exponential term on one side, everything else on the other side. Now you have to ask yourself, do I see here 10 or factors of 10 in this question? Do you see 10, 100, 1000, 10,000 like this here? No. Then if you don't see, then you're going to take ln on both sides. If you don't see, you will take ln. If you see, you're going to take log. That's the difference. Now you use the property. What is ln 5 to the power of x? Cat, what do you think is ln 5 to the power of x? You're mute.
Sorry,
Yeah.
I might be wrong. Sorry, my family. I think you might move the x to the front, or
Exactly. Yes, you're correct. So it becomes x ln 5 is equal to ln 134. Now I just need x. What do I do, Cat?
you would divide by ln 5 on both sides.
Correct. So you get x is equal to ln 134 over ln 5. Can you use calculator and tell me what's the value?
Yeah. Over ln 5. I still struggled a bit to find out how to make ln.
ln here. So can you show your calculator? I cannot see it. There must be something written as ln here. See here?
I think we have the same one. Oh, never mind. We don't. Oh yeah, I see that. Okay. Yeah. ln 134 divided by ln 5. 3.04.
3.04. Perfect. Okay. Caesar, with this problem, can you write 8,000 as 10 to the power of something?
I didn't even check. I'm not gonna lie.
The thing is,
bet-
if you cannot note 10 to the power of something will look like either 10,
Oh,
100.
no, can't.
Yeah. So
Oh,
you cannot write that.
You can do the 10 though, right?
Yes. So what property? Next, isolate. It's already isolated. What's step 2? Whether I will take log or ln.
Log.
Why I'm taking log? What's the reason I'm taking log, not ln?
Because step 2 says if you see a 10 in the equation, use log.
Yeah, exactly. Perfect. And what is log 10 to the power of x?
That equals x log 10.
Okay. Is equal to log 8,000.
Equals log 8,000.
And what is log 10?
1?
Yes,
Right?
yes, because log base then base is 10, right? So it becomes log 10, 10, which is 1.
1.
So you get basically x is equal to log 8,000. And what's the approximate when you solved it? What did you get?
3.903.
Perfect. Yes, 3.90. Are you getting it, Kat?
Quick question.
Yeah.
Say that was 100
This
to
one?
the power of x.
Okay.
So would that be 2? So would that make the left side 2x equals log 8,000?
Yes, exactly. Yes.
And then you would have to divide by 2
Yes.
after. So would you divide log 8,000 by 2?
Yes.
Or would you divide 3.903 by 2?
No, log 8,000 divided by 2.
Got it. Okay.
Okay, let's do one more problem here let's do one more problem. So you're given 40 e to the power of 0.6 x minus 3 is equal to 237. You're given this thing. Okay, Kat, can you tell me what's the exponential term here? Exponential term.
You mean which one is the equation going to be?
And no, exponential term looks like this: b to the power of m. B could be any number.
Oh, so it would be 40e to the power of 0.6x?
Not the number in front. It's just this thing. It's just e to the power of this thing, not 40. Okay?
Oh, so e to the power of 0.6x.
Because yeah, number in front is not the exponential, just a number and with a power. That's the exponential. Okay? So in this case, my exponential is e to the power of this thing. And remember, my first step is always to isolate the exponential, keep everything else on the other side. Do that. I just want this term on this side. Everything else I want to take on the other side. How do I do it?
You would add 3 on both sides.
Absolutely
first.
correct. So you get 40 e to the power of 0.6x is equal to 240.
And then we would probably want to get rid of the 40, right?
Yes.
So would we divide by 40 on both sides?
Absolutely. So you get e to the power of 0.6x is equal to 6. Now,
Okay, so where should we go from there?
okay, now again we are gonna do the same steps. Step 1 was to isolate. We isolated in this case. Okay, step 2 is, do you see anywhere 10?
No.
Then what are you going to do? Whether you will take log or ln?
You would take ln.
Yes, since you don't see 10, you're going to take ln on both sides. So it becomes ln 6. And what's my next step? Which of the three properties are you going to use?
Would you use ln ex to the x?
Exactly. Yes.
Equal x? Okay.
So in this case, what does it become? ln e, you have 0.6x. So what do you get?
Would I keep the x in the 0.6 or would I do something with it?
What happens is, so if you see the property, what does this property say is, if you have ln e to the power of x, it says ln and e gets cancelled. Whatever is in the power, that's your answer. Okay.
Oh, okay.
So in this case, what's your answer?
So would it be 0.6x equals ln 6?
Perfect. Yes, correct. Now I just need x. How do I find x?
Divide by 0.6 on both sides.
Okay, divide by 0.6. You get x is equal to ln 6 divided by 0.6. Use a calculator and tell me what's the approximate answer.
It equals 2.986, which would be
2.99.
3.
2.99 and 3, yes. You got it. Okay, let's do one more problem here. One more problem here is example. You have to do it yourself. You have 7e to the power of 2x minus 5 is equal to 58. Do this problem by yourself right now. Caesar, you're gonna help me with this problem.
Okay. So I got, so I added 5 to 58 to try to isolate the
Okay.
exponential, the exponent, whatever it was. Yeah. And then I got 7e to the 2x. And then I divided by 7 to isolate it even more, which gave me e to the power of 2x equals 9.
Okay.
And then I didn't see any 10s, so I did ln. So I got ln e to the power of 2x equals ln of ln that we wrote down.
Mm-hmm.
I got 2x equals ln 9, and then so then I would divide ln 9 by 2.
Yes.
I got x is approximately 1.098.
Yeah. So it is 1.10 approximately. So basically we did, okay, now we are done with exponential functions. So there are two methods of doing exponential functions. First, you try to make the base same. If you can make the base same, you put the power equal to each other and solve. If you cannot do it, you have to isolate, take log if you see 10, otherwise take ln and then solve. Okay. Next thing we are doing is solving logarithmic function. How to solve?
I have a quick question, Professor.
Yeah.
This might not be a problem, but like, so if say on this last one that we did, if 58 was to the power of like 4x, then we wouldn't be able to solve that, would we?
If you're saying 58 was like, suppose
if there's something with an exponent on the other side of the equal sign.
There is problems like that, Caesar. It's easy. It's the same method. You keep both of them. Take one exponent on the other side, other on the other side, and take ln on both sides. But you do that, you will do it when you take higher mathematics. Right
Okay,
now,
so we're not here. Okay.
Yeah, in your syllabus, it's not included.
As long as it's not going to be.
Yeah, it's not there in your. I was checking that, but it's not there.
Okay, thank you.
Yeah. Next we are doing is solving logarithmic. So exponential we have done two methods. For logarithmic also there is two methods. Okay. First method is, okay, first you're going to write steps. I'm going to writing method, first method. First method says express the equations in the form log b m is equal to c. Log b m is equal to c. You can express it in this form. Okay. And also you can say, if you're expressing in this form, you can say you can use the properties of log b m plus log b n is equal to log b m times n. If you have log b m minus log b n, it is basically log base m over n. One of these properties you can use and express it in this form. So basically I need just one log on one side and constant number on the other side. One log on one side and constant on the other side. Next thing it says, use the definition of log to rewrite the equation in exponential form. So you convert the logarithmic form into exponential form. So if you have log base m is equal to c, how do you convert it into exponential? Caesar, do you know it? How to convert log into exponential?
I feel like I know it, but
we did this. Yes, we did this. See, Kat, do you know how to do it?
Oh, is
no. How do you do it is, this base will go on the other side, this base will go on the other side, and c will go in the power, and it will be equal to m. That's how you write the exponential form. So you take this
last class, right?
Yes, we did this. We did in last class. This b will go on the other side, it will become the base, and the c will go in the power, and it will be equal to m. So you have to write the logarithmic in the form of exponential, and you know how to solve exponential functions. Solve for the variable. Okay. But in this case, there is an important step here. Step 4. Check proposed solutions in the original equation. So whatever you get your answer, you're going to put it in your original equation. Include in the solution set only values for which m is greater than 0. I will explain you all these steps, don't worry. Okay, so example, let's do an example here. Okay, so you have log 4 x plus 3 is equal to 2. Log 4 x plus 3 is equal to 2. In this case, I already have log on one side and constant on the other side. I don't have to rearrange or do anything. It's in this case I already have. So I move to my step 2. I have to convert my logarithmic into exponential. Kat, what do you think? How will you convert it?
I think it would be 4 equals. Actually, wait, because is 4b? Oh, okay, then I don't know if that would work. Would it be x plus 3 equals 4 to the exponent of 2?
Yes, exactly.
Okay.
So that's how you can remember. This 4 goes here. It will push this 2 on the top. It becomes 4 to the power of 2 is equal to x plus 3. Okay. Step 3 says solve for the variable. What's the variable here, Kat?
The variable is x.
Yes, we are trying to find x. What is 4 square?
16.
16 is equal to, you get x plus 3. I need x. What do I do?
You subtract 3 from both sides.
You subtract 3 from both sides. You get 13 is equal to x. But this is not your final answer. This is not your final answer. You need to do step 4, which is checking. How do you check is this 13, whatever answer you got. In the original equation, whatever you have log something, you're going to put in there. What do you get? 13 plus 3, which is 16, right? So your m was equal to x plus 3. In there you will put your 3. You get 16, which is greater than 0. It's supposed to be positive. If it's negative, you will not include it. If it makes your this thing negative, you will not include it. If this thing remains positive after plugging in value, you will include those answers.
Wait, so the answer has to be greater than 0?
Yes. After plugging this in here, your answer should be, since if I plug in, it's coming out to be 0, does 13, x is equal to 13 is a solution. Let's do one more problem here. So you are given 3 ln 2x is equal to 12. 3 ln 2x is equal to 12. Okay, Caesar, how do you do this?
Let's see. So this is like saying that 2x
First of all, Caesar,
equal.
first of all, I want ln on one side, everything else on the other side.
Yeah, okay. So divide by 3 to get rid of the 3.
You get ln 2x is equal to 4. What is ln? Log base what?
10?
No.
No?
In general, if I say just log, that is log base 10. When I say ln, it is log base e.
What?
So you get log base e, 2x is equal to 4. Very important. Make sure you remember this. When it's just log, that means log to the base of 10. When it says ln, that means log base e. Now convert into exponentials.
Now you got 2x equals e to the power of 4?
Yes, correct. I just need x. Solve for x.
Now divide by 2.
So you get x is equal to e to the power of 4 over 2. Now you're not done here. You're not done. You have to check this answer. Where will I put this e to the power of 4 over 2?
In the original equation. So 3 ln
Yes.
to times 2x to, yeah.
So basically you just have to, you put it there. So let's check here. Check here. So you get 3 ln e to the power of 4 over 2 times 2 is equal to 12. Yeah, this thing is supposed to be positive. So you get 3 ln, this 2 gets cancelled, you're left with e to the power of 4 is equal to 12. Note e is 2 point something. 2 point something. So 2 point something to the power of 4 will always be, this is your m, it will always be greater than 0. Does e to the power of 4 over 2 is a solution. We just have to check the m. This is my m here next to ln. E is basically 2 point some number. If I multiply 2 point some number like 4 times, it will still be positive. So that means this is my solution.
I have a quick question. In the beginning of the equation, when we went from log 2 or log e 2x equals 4, how did we just get 2x equals e to the 4? I don't
We
understand
convert it
that.
into exponential, Kat. Remember how we convert log to exponential?
Oh, okay. Now it makes more sense.
Yeah. Let's do 2 more problems and then I'll go to the next method. And that would be the last method. Okay, let's see here. So I want you to try this problem here. So first is log 2x minus 4 is equal to 3. And then you have 4 ln 3x is equal to 8. First one you will help me, Kat. Second one you will help me, Caesar.
Okay. I believe for the first equation, first you would turn it into the easier form of it. I think it's called, what is it called when you turn it into the shorter form?
Exponential form.
Exponential form. Okay, so it would be x minus 4 equals 2 to the 3.
Yes, correct. So you get x minus 4 is equal to what?
8.
Yes, perfect. So I add 4, I get x is equal to 12.
8.
But I don't know this is my answer or no. Where will I put this to check, Kat?
You would put it back into the original equation.
Yes, you put that in the original equation. So you get log 2 12 minus 4 is equal to 3. Right? What is log 2? What do you get? What is 12 minus 4?
8.
8. Technically, Kat, you don't have to solve that much. You can do it. If you use calculator, you will see you will get 3 is equal to 3, which is true. That means it's a solution. If not, what you can do is just look at your m. Log to whatever m you have here. This whole thing. Just put in here 12. It becomes 12 minus 4, which is 8, which is positive, right? If it's positive, then it's your answer.
Okay, so for some reason I thought it just had to be bigger than 0.
Yes.
It just has to be bigger than the other side of the equation.
No, it has to be bigger than 0.
Oh, okay.
Just bigger than 0. So if you just check in here, x minus 4. You will not put in the whole equation, just in x minus 4, your 12. Which comes out to be 8, which is greater than 0. So that means that's your answer. We'll do example where it is not. I will show you. Okay. Caesar, how do you do this one?
Okay, so I divided the 4, get ln 3x equals 2.
Mm-hmm.
And then I moved it to exponential form.
Mm-hmm.
And I got 3x equals e squared.
Yes.
And then I divided by 3. And I got x equals e squared over 3.
Okay, and how did you check?
I plugged it in.
Mm-hmm.
And I got
What's your m? What's your m in this case?
e.
E 3x, 3x. That's
Oh,
your m.
Your m, yeah.
So in just m, not in the whole equation, just in m you're gonna plug in. So you get 3
Right.
times e square over 3.
Right.
Which is just e square, and e is a positive number, that's why it will be positive.
Awesome. Yep.
Does x is equal to e square over 3 is a solution.
What happens when it's not a solution?
Then you don't put it, then that is not a solution. Then you have no solution.
Okay.
Yeah. Let's do one more problem, you'll get to know. Let's do one more problem here. So you have log 2x plus log 2x minus 7 is equal to 3. Note now you have two logs and one constant. 2 logs and one constant. Can I make this into one log?
Yes.
Yes. Addition changes into multiplication. So it becomes x times x minus 7 is equal to 3. Now you know how to solve this problem. Okay. Caesar, what does it become?
X squared minus 7x equals 2 to the power of 3.
Perfect, which is x square minus 7x is equal to 8. In this case, when you are solving problems like this, you have to use quadratic equations. So you have to take everything on one side and put it equal to 0. Use quadratic equation. What's your a, what's your b, and what's your c, Caesar?
My a is 1, my b is negative 7, and c is negative 8.
Yes, let's put in the quadratic formula. X is equal to minus b plus minus square root of b square minus 4ac over 2a. So you get 7 plus minus square root of negative 7 square minus 4ac over 2a, which is 7 plus minus square root of 49, 32 over 2. Over 2. 7 plus minus 8 over 2. So basically you get x as 7 plus 8 over 2, and you get x as 7 minus 8 over 2, which is 15 over 2 . So it's 81. 9, it's 9. It's 9. You get 16 over 2. And you get minus 2 over 2, which is negative 1. You get here 8. You get 8 and negative 1. Both of you got the same thing? Okay, once you got this, you have to check. Let's check. Okay, here in this original equation, now rather than having 1m, you have 2m. 1m is x and 1m is x minus 7. You have 2m in this case, in this problem. You're going to put in both. When I put here 8, this is 8. When I put here 8, I get 8 minus 7, which is 1. Both are positive. That means x is equal to 8 is a solution. Now let's put negative 1. I have x as negative 1. 1 is x, my m, and 1m is x minus 7. I put here negative 1. Note, I already get negative number here. That means this is not a solution. This is not a solution. Thus the final solution is
X equals 8.
yes, x is equal to 8 only. Did you get it, cat? Why x is equal to negative 1 is not a solution? Yeah. If I put in one of my m's, it is giving it as a negative number, so it is not a solution. I want you guys to try this problem here. You have log x plus log x minus 3 is equal to 1. Log x plus log x minus 3 is equal to 1.
What would be because I know you have to put it in exponential form, but what would be
First you have to combine them into 1. How do you combine them into 1?
you would multiply
Yeah, it becomes log what?
log x squared minus 3x equals 1.
Yes, perfect. Okay. When nothing is my base, what's my base?
10?
Yes, correct.
Okay. X squared minus 3x equals 10. Would it be x squared minus 3x equals 10 to the 1?
Yes, exact. And 10 to the power of 1 is
10.
correct. And how do you solve this?
From there, you would have to subtract 10 from both sides.
Yes, you get x square minus 3x minus 10 is equal to 0. Then you figure out your a, your b, your c, and use quadratic. What's your b and c?
Negative 3 and negative 10.
Okay, can you use quadratic formula and tell me what did you get your x as?
Yeah, I'm just gonna write down that equation real quick.
Yes, perfect. Find the final answer and let me know.
Okay, so it'd be x equals positive 3 plus minus square root negative 3 squared minus 4 times 1 and negative 10 over 2 times 1.
Yes.
From there, you would just do 3 plus minus square root 9 plus 40 over 2.
Yes.
And then And then you would get x equals 3 plus minus square root 49 over 2.
Which is square root of 49 is what?
7.
Yes. So you get 3 plus 7 over 2, 3 minus 7 over 2.
What would you do from there?
So you get 3 plus 7 over 2, right? What is 3 plus 7? 10 over 2. Which is 5.
Okay.
And then 3 minus 7 is negative 4. Negative 4 over 2 is negative 2. But you are still not there. You have to check. Okay, Cat. What's your m in this case? What are your m's?
M would be x squared minus 3x.
No. In the first original equation, you have to check m. Original equation is this one, right? The question. So what's here? M is next to x. Next to log. Whatever is next to log. What's next to log? First log here? X, right? Log x.
Yeah.
So that's
X.
your first m. What about the second m?
X minus 3.
Correct. So for both, you have two m's, x and x minus 3. Let's check. When I put 5 here, I'd get 5. When I put here 5 minus 3, I get 2. Both are positive, right?
Mm-hmm.
Thus 5 is a solution. What about negative 2? When I put here negative 2, I directly get less than 0. I don't even have to check for the second one. Does x is equal to negative 2 is not a solution. So your final answer is just x is equal to 5. That's it. In logarithms, I again repeat, in logarithms, for exponential functions, you don't have to check. But when you are solving logarithms, you have to check. Very, very important step is to check. Okay. Now we are doing the last kind of problem. This is the last problem, 2 problems more, and then we are done for today. Okay. Next is, so far what we did is, you have logarithms. What you do is, you keep log on one side and take constant on the other side. That's what you did. And then you convert it into exponential and then solved. Yeah, you have that kind of problem. Okay. Next thing, what happens when you have logs on both sides? When you have logs on both sides. So second method for logarithms. Second method for logarithms. So it says, express step 1. Express the equation in the form log base m is equal to log base m. So if you have 2 logs and you cannot combine, what you have to do is take one log on one side, take other log on the other side. I need 2 logs on separate sides. Okay, one on one side, one on the other side. Okay. Second step says, step 2 says, if you have log base m is equal to log base n, if you get something like this, then m is equal to n. If you have log base m is equal to log base n, my bases are same, then I can say m is equal to n. Okay. Step 3 says, solve for variables. Step 4 is, check for m greater than 0. For my all m and n greater than 0. Check for m greater than 0 and n greater than 0. It's technically the same thing we are doing, it's just that this thing has changed. Example, you have ln x plus 2 minus ln 4x plus 3 is equal to ln 1 over x. You're like, oh my god, there are 3 ln's. I just needed 1 ln. You don't have complex ones. Okay, yes. How do we do this one here? Okay. Caesar, this side, can I do something and make it into 1 ln?
Yes, you can divide them.
Yes.
So ln x plus 2 over 4x plus 3
is equal to ln, you get 1 over x. So subtraction changes into division, addition changes into multiplication. You got this thing. Done with the first step. They wanted each log on both sides and we got it. Steps 2 says if you have log this is equal to log this, your bases are the same and I have both ways ln. Then in step 2, basically my x plus 2 over 4x plus 3 is equal to 1 over x. I can write it like this. The reason is both sides I have ln and ln have the same base e. If my bases are same, I can put it equal to each other. Now I need to solve it. I need to solve this and find the value of x. Okay. Okay. How do I get cat? I want to get rid of this denominator x. How do I get rid of this x?
Would you multiply by the opposite or by the opposite fraction?
Yes. So here x is what? It's dividing, right?
Mm-hmm.
I multiply both sides with x. Okay. When I multiply here with x, what does it become is, if you open here, you multiply, it becomes x square plus 2x is equal to over 4x plus 3 is equal to this x and this x gets cancelled. You're left with 1. I have another denominator here, cat. 4x plus 3. I want to get rid of this 4x plus 3. How do I do it?
Would you multiply by 4x plus 3 over 1 by the whole equation?
Exactly. You multiply by 4x plus 3 because I want to get rid of denominators. I don't want to deal with denominators here. In this case, this 4x plus 3, this 4x plus 3 gets cancelled. You're left with x square plus 2x is equal to anything multiplied by 1 gives me the same thing. And you know how to solve these. Take everything on one side. You get x square minus 2x minus 3 is equal to 0. And we are going to use quadratic formula. Your a is 1, b is negative 2, c is negative 3. So you get x is equal to negative of negative 2 is 2 plus minus negative 2 square is 4 minus 4 a c over 2a. So you get 2 plus minus square root of 4 plus 12 over 2. Get 2 plus minus square root of 16 over 2, which is 2 plus minus 8 over 2. So you get 2 plus 8 over 2 and you get x equal to 2 minus 8 over 2, which is 10 over 2, which is 5. Here you get negative 6 over 2, you get negative 3. Once you got this, looking at your original equation now, cat, you got x as 5 and you got x as negative 3, right? This was your original equation. Can you tell me what are your m's in this case?
How did you get 5?
10 over 5?
Yeah, I think you lost me in the work.
Oh, okay. Let's see here. Did you get root 16?
Yeah.
That becomes 2 plus minus 8 over 2?
No. It's 4.
Oh, okay. You're correct. It's 4. You're correct.
Okay.
Yeah, it's 3. And they get you minus 4 over 2. You're correct. Thanks for correcting. You get negative 1. So you get 3 and negative 1, right?
Yep.
Okay, correct. Thanks for correcting this. I'm sorry. Okay. You got 3 and negative 1. So Kat, what are your, this is my original equation. Can you tell me what are my m's?
So it'd be x plus 2 and 4x minus 3.
What about this side?
The same thing.
1 over x also.
Mm-hmm.
Because this is also next to
okay.
ln, right?
Yeah.
So all of these, 4x plus 4x minus 3 and 1 over x, all of these. So I'm going to check in all of this. Let's check for 3 first. When I put 3 here, I get 3 plus 2, which is 5. So this is correct. When I put 3 here, you get 12 minus 3, which is 9. That's also correct. When I put 3 here, I get 1 over 3, which is 0.3, which is also positive. Does x is equal to 3 is a solution.
Yeah.
What about here? Negative 1. You get negative 1 plus 2, which is 1. That's greater than 0. That's good. Let's put here negative 1. You get 4 times negative 1, negative 3. Negative 4, negative 3, you have negative 7, which is less than 0. So I don't even have to check for the next one. Even if 1 is 0, does this thing is not a solution. Any questions, anyone? This is the last kind of problem we are doing today. One more example we'll do and then we are done. Let's do one more example. So you're going to solve this by yourself and then we are done. That's it. That's the last question for today. Do this and give me the final answer. Okay, Kat, first step.
You would, since it's subtracting, you would do ln 7x minus 23 over x plus 1
Yes.
equals x minus 3. Yeah.
Then
I'm pretty sure
you can say ln and ln, both sides are ln, right? The ln gets cancelled. You're left with x minus 3 is equal to 7x minus 23 over x plus 1. Okay? Okay. Now, I need to get rid of the denominator. How do I do it?
multiplying everything by x plus 1.
Okay, then I multiply by x plus 1 both sides. What do you get? What is x plus 1 times x minus 3?
X squared. Hold on, wait. This is a hard one. X squared plus 3x.
Minus 3x.
Oh, minus 3x plus x minus 3.
Perfect. It's equal to what?
Equals 7x minus 23.
Correct, because that x minus 1 and x minus 1 gets cancelled. Correct. Let's solve it. X squared. What is negative 3x plus x?
2x.
Negative 2x.
Negative 2x, sorry.
Negative 3 and then you have 7x minus 23. I want to take everything on one side.
You would minus 7x minus 7x plus 23 on both sides.
Correct. So you get x squared minus 9x plus 20 is equal to 0. Use quadratic formula and tell me your A is 1, B is -9 and C is 20. Caesar, did you get the values of x?
Yes.
Which is?
I got x equals 5 and x equals 8.
8.
Yes.
Okay. Let me use the formula. You get 9 plus minus square root of 81 minus 4.
All right, never mind. X equals 4.
Yes, you get x equal to 5 and x is equal to 4.
4.
Yes.
I knew that was wrong too. I looked at it and I was like, something's wrong. Okay.
Okay. So what's your m's in the original questions?
X minus 3, 7x minus 23, and x plus 1.
X plus 1. So you have x minus 3, 7x minus 23 and x plus 1. When I put here 5, what do I get? What is 5 minus 3?
Positive 2, so that's good.
Yeah, positive 2. Okay. What is 7 times 5? 35, right?
Yeah.
35 minus 23?
Positive 12.
12. That's also positive. And 5 plus 1 is 6.
Yep.
All are positive. Thus x equal to 5 is a solution. What about 4? When you put 4 here, what do you get?
4 minus 3 is positive 1. That's okay. 7 times 4 is 28 minus 23, which is positive 4, which is fine. 4 plus 1 is positive 5, so that's okay.
Yeah, all of them are greater than 0. Thus, x is equal to 4 is also the solution.
Both solutions.
So, does your answer will be 5 and 4 both. X is equal to 5 and x is equal to 4. Both are your final answer.
Awesome.
Any questions, both of you? No? Okay. So that's it for today.